So let's take a look at the last part of section 2.2. So remember, the whole goal of unit circle trig is to figure out a coordinate. So we've done the coordinates 30, 45, and 60. Now what we're going to look at is what happens if we have multiples of those angles, right? Meaning those angles are now in other quadrants. Okay, and I might have shown you like a quick sketch yesterday, and it's very, very similar. Really all that ends up happening is you have a negative in front of one of the fractions. Maybe negative a half instead of positive a half, or negative root 2 over 2 instead of positive. Right? But we'll go through it. For the first problem we do, we'll go through all 6 trig functions. But then after that, we're just going to do one trig function per problem, okay, like on the test. Like cosecant, sine, cosine. Okay, just one per problem. So, as I said, we're still using the same 2 triangles from yesterday. It's just imagine flipping or reflecting them into other quadrants. Okay. So, when you reflect or you mirror image something to a different quadrant, does mirror imaging something change the lengths of it? No. So that's why the fractions are still the same. They're just in other quadrants. So you might have negatives instead of positives. So other than that, there's nothing else we really need in terms of an explanation. You do have to remember the fractions that are going to come up. So when we're dealing with a 45-degree angle, what fraction comes up for both the x and the y? Square root of 2 over 2. Might be negative, might be positive today. We don't know. So you got to remember that one. And what are the 2 fractions you got to remember for 30s and 60s? Yep, Dave.
1/2 and square root of 3 over 2.
1/2 and square root of 3 over 2. Might be positives, might be negatives. Okay. Those are all we got to remember to do this. Okay, so let's pretty much just going to do examples. That's all we're going to do. So let's see if we can find the 6 trig functions of 135. All right, so we've got 90. We've got 180, and now we got to figure out where 135 is. Any angle that we do is either going to be in one of 3 spots in the quadrant. It's going to be right in the middle. It's going to be closer to one axis or closer to the other axis. It depends if it's the 30, the 60, or the 45. So where's 135 here compared to 90 and 180? Right in the middle? Closer to 90, closer to 180. It's right in the middle. Yep, 135 is exactly halfway between. So, I'm going to put a dot right there. So if 135 is halfway between, how far is it from 90 to 135? 45. So that tells you that this problem is going to be about a 45, 45, 90 triangle. So if you make a triangle out of it. The goal is to figure out how far you move from here to here, and then how far you move from here up to here. So the red side is your x, the green side is your y when you're writing your coordinate. All right. And again, I didn't label it, but if you wanted to put this in, we just said that this is 45 degrees, like this part right here. So if this part's 45, then so is that one. Okay? Because together they make up a quadrant, right? Which is a 90. Okay? And then this is a 45 as well. So basically, if your angle ends in a 5, and it's the kind of angle we're dealing with today, it's a multiple of 45. It can't end in a 5 and be a multiple of 30. It doesn't make sense. All right. So let's start with the bottom side. Andrew, in the 45, 45, 90 triangle, how long is the bottom side?
Well, it's usually the same side. Well, it's the x side, and it's the same as the y side.
Yep, it's going to be the same as the y. So can you tell me what they're both going to be? think back to that fraction you got to remember with a 45. So it's not going to be a coordinate. It's just going to be a fraction. It's got a square root in it.
Square root of 3 over 2.
That's for the 30
Or
and 60
square root
stuff.
of 2 over 2.
Yeah, square root of 2 over 2. So this side is root 2 over 2. That side is also root 2 over 2. Now, let's write the coordinate. What do I have to be careful about when I write the coordinate for 135? Yeah.
The signs.
Okay, what do you mean by the sign?
Like the negative column.
Okay, so why do you think one of those should be negative?
Yeah.
Which one?
The x.
Yes. You went left and you went up. So the x should be negative. And the y should be positive. That negative is the only difference with all the problems we're doing today that aren't on the calculator. Okay. You've got a negative in front of one of them. Everything else stays the same. So any questions on how we got the coordinate for 135? Okay, and if you weren't here yesterday and you're like, where does that square root of 2 even come from? Well, that's what we went through yesterday. We can do the Pythagorean theorem, and when you solve it, that's what it comes out to. Now that we've done it, we're not going to go through that again. So let's start with sine. Brianna, what would be the sine of 135?
Square root of 2 over 2.
Yep, it's the y value. So square root of 2 over 2. That's it. Sebastian, how about my cosine of 135?
Negative square root of 2 over 2.
Yep, just the x value. So just copy that down. Right, and my tangent. So for tangent, like I said, I just imagine going like this. Just take y and divide by x. And it's basically written like right there for you. So what do you get if you divide y by x?
-1.
Yeah, they're opposites. Root 2 over 2, negative root 2 over 2. Anytime you divide two numbers that are opposites, you always get -1. All right, my cosecant. Courtney, how do once I have the sign, what do I do to get the cosecant?
So it's 1 over y.
Okay, which means basically to do what?
Divide it. Multiply it.
Thinking of another
Flip
word.
it.
Flip it, yeah, flip it. So just take the sign and flip it. Which, flipping it basically means to do 1 over. But just think of it as flipping. So Cal, when I flip that, what do I get to start?
2 over the square root of 2.
Yep. And can anybody tell me, we've done this one probably 3 or 4 times now, what happens when you fix having the square root in the bottom? What do you get?
Square root of 2.
You just get the square root of 2. Yep. Okay. Now that we've got the cosecant, the secant's not the same, but it's close. What's the secant going to be?
Negative.
Just the negative square root of 2. Just same one we just did, throw a negative in front. And my cotangent. How about Anthony? What's my cotangent going to be?
-1.
-1, right? Because if you make this a fraction and you flip -1 over 1, it's still -1. Okay, so again, this setup would be 6 different problems on the test, okay, where you give me the coordinate, and then I would ask you for one of the 6. And that's how the rest of the parts are going to be set up, just 1 per problem. Okay, so any question on that? All right, let's look at this one. So cosecant of pi divided by 4. Okay, Justin, you might be able to do it right away without even doing this, but if you had trouble figuring out the coordinate, what could you do first?
Multiply by 180 over pi.
Yep, you can multiply by 180 over pi and change it to degrees. And does anyone remember what that one is? Pi over 4 is 45. Yeah. Okay. So we're looking for a 45-degree angle. Here's 0. Here's 90. Where's 45? Middle? Closer to 90? Closer to 0? Right in the middle. And I already told you the trick earlier. If it ends in a 5 with the angles we're working with, it's a multiple of 45. I'm not saying every number that ends in a 5 is a multiple of 45. Just the ones that we're doing in this lesson. Like 45, 135, 225, 315. Okay. All right. So my coordinate here, how about Stephen?
A half and half? Or 45 degrees.
So half always has to do with the 30-60. So what's the length? Do you remember the length of each side on the 45? It's the one we just did.
Is negative, it means square root of 2 over 2.
Okay, so the bottom is square root 2 over 2. How about the height?
And the same thing.
Same thing. And now when I write my coordinate, both the x and the y are going to be what? The same, and they're both positive this time. Yep. So coordinate, square root 2 over 2, comma square root 2 over 2. Okay, so we got the coordinate. That'd be half of what I'm looking for. And now I want the cosecant. So Megan, to find the cosecant, how do I do that?
You take the y value and flip it.
Yep, exactly. Take the y value, flip it. So when you do that out, you're going to get 2 over the square root of 2. Again, we've done this one a lot. So you end up with just the square root of 2. Okay, any questions on that? Like I said, I think for the 45s, you don't need to really sketch it as much. I can do it if it's helpful. It's more important with the 30s and the 60s, because then you got to get the 1/2 and the root 3 over 2 in the right order. Okay, let's try 225. So 180, 270. You can label the whole thing if you want, but you don't need to. So where's 225? Closer to 180? Closer to 270? Right in the middle. Yep, right in the middle. Because it's right in the middle, it means it's halfway through the quadrant. A quadrant is a 90, halfway through it is a 45. So we're dealing with the 45, 45, 90 again. Yashira, how long is each side?
They're both negative square root of 2 over 2.
All right, so I'm just going to write down square root of 2 over 2 right now for the length. So they're both square root of 2 over 2 if you were to measure them. Now, when we write it as a coordinate, we got to do what Yashira said. Make sure they're both negative because you went left and down. Square root of 2 over 2, negative square root of 2 over 2. So there's my coordinate. Now they want the sine. So Madison, the sine is, what's the formula for sine again?
It's the y.
It's the y. And what's my y here?
Negative square root of 2 over 2.
Yep, the second one. So negative root 2 over 2. Done. Okay. Any questions on that one? So we're not going through every single one. I mean, I could ask you for the cosine or the tangent or the secant, but that's all it's all the same stuff. Okay, and let's try cosine 7 pi over 4. So kind of a shortcut to convert this one in your head is you've got a pi over 4 right there. How much is pi over 4? 45. So this is really just 45 times 7. Okay, it's pi over 4 times 7. So if you do that out, 45 times 7, that's 315.
Plus 0.
Bless you.
Thank you.
No problem, man.
I appreciate it, thank you.
Anytime, bro.
All right, so we got 270. Now this is 360, or you could call it 0. It doesn't matter. It's the same thing. Where is 315? Yep, it's right in the middle. It's halfway between 270 and 360. If you're not sure, just do 360 minus 315 and see what you get. You get 45. Right, so it's 315 is 45 degrees before 360. So it's right in the middle. Make your triangle. Mark 315. And now my coordinate. How about, let's see, Grace, let's just start with how long each side is. Don't worry if they're positive or negative.
The square root of 2 over 2.
Yep. So both sides of square root 2 over 2. But we got to make sure we put positives and negatives where they go. So Alex, is there any negatives for 315?
The y.
Yeah, just the y, not the x. So square root 2 over 2. Negative square root 2 over 2. Okay. Any questions on how I got that coordinate? Okay. And now my cosine. Matt, what's the cosine of 315?
What? It's square root of 2. Where's it negative?
Well, square root of 2 would actually be the secant.
Yeah. There we go. Yeah, that's good. Negative square root of 2 over 2.
Square root of 2 over 2. Yeah, just the x value.
Out of half of it. Dude, we really appreciate that much. This report I need.
Any questions on that one? Okay, so now we've done a 45-degree angle. We've done it in every quadrant. Okay, so we've done those. So with the 45-degree angles, there's basically, let's see, 24 different questions I could ask you. All right, I could give you a 45-degree angle in the first quadrant and ask you any one of the 6, sine, cosine, tangent, all that stuff. Or I could give you the 45 over here in quadrant 3 or quadrant 4. So that's really 24 different questions just on those. All right, let's try this one. Tangent of 120. What's different here? Just looking at the angle.
Not a multiple 45?
Yeah, 120 is not a multiple of 45. So that one's a multiple of 30. All right. So now we got to kind of switch gears and start thinking about the other 2 numbers that are involved.
You can do 60.
What's that?
60.
Yeah, multiple if it's a multiple of 60, then yeah, it's multiple of 30 automatic. Yeah, but yeah, it's gonna have something to do with 30s and 60s. Yeah, 30s and 60s go together. All right. So here's 180. Here's 90. Now, it's kind of important that you draw this somewhat accurately to be able to figure this out. Where is 120? It's closer to 90. Okay, so I'm going to put it, might even be exaggerated a little bit, but I'm going to definitely put it closer to 90. Now, what am I going to draw using that point as one of my vertices? So what am I going to draw now?
Triangle.
Yeah, let's make a triangle out of it. Draw your hypotenuse, always right to the origin, and then draw a line perpendicular to the x-axis. Okay. As long as you put the 120 in a somewhat accurate spot, you should be able to tell which side is the short side and which side is long. Which side is the short side here? The base or the height?
The base.
The base. So the base is the short side. The height is going to be the tall side. Okay, what are the two numbers that always come up when you're dealing with the 30s and the 60s? Yep, so just put these off to the side. Those are the two numbers. Now, if you're still not sure why this isn't a 45, 45, 90, well, look at that number first. It's not a multiple of 45. And then look at your problem. How far apart are 90 and 120? 30. So there you go. This part on the outside right here is a 30. So that means this part on the inside is a 60. And together they make a 90. Okay, so any questions why this one has the 30-60? Okay. Now we got to put these numbers in the right spots. Which number here is the smaller? 1/2 or root 3 over 2? The 1/2. So smaller number goes with the smaller side. Bigger number goes with the bigger side. Now from the picture you should be able to figure out which one of those is x and which one is y. So let's write our coordinate. Anyone think they can give me coordinate for 120? Yep.
-1 comma.
Yep. So negative 1/2. Yeah, I know what you mean. And then up root 3 over 2.
Yep.
Okay. So we got the coordinate. Now they want the tangent. What's my formula for tangent? Y over x. So we're going to do root 3 over 2 over negative 1/2. What's going to cancel out there? 2's. So those are gone. And what are you left with when you divide? Yep, exactly. Negative square root of 3. And now just with that angle right there, there's 5 other questions I could have asked you. I could have asked you for the sine, the cosine, the secant, any of those other ones. But I just did one of them. So any questions on that? Okay. Okay, let's try. I mean, we can keep doing as many as we want. There's a lot more, but we'll practice a couple more. Secant of 690. It's already in degrees, so we don't have to worry about changing it to degrees. But what might we want to do with the 690? Yeah?
Subtract 360.
Yeah, let's subtract 360. 690 minus 360 gives me 330. Okay, so now I'm done changing the angle to something easier to work with. That's as easy as it's going to get, 330. Now you've got to figure out where 330 is on the circle. Here's 270, here's 360. Where's 330? It's closer to 360. Okay, it's just 30 degrees away from 360. So put it right there. After you put your point, now you draw your
Legs.
Yep, draw your legs, make the triangle. All right, so let's do that. Draw a line to the origin, and then draw the other leg. Okay, so here it's pretty clear. There's my short side. There's my long side. Pat, long side is going to be what number?
Square root of 3 over 3.
Yep, square root of 3 over 2. And the short side, how about Brandon? What's my short side?
1/2.
Yep, 1/2. Okay, so now let's write our coordinate and then we'll do the secant. So Riley, what is my coordinate for 330?
The square root of 3 over 2,
Okay,
and then negative 1/2.
perfect. It's in quadrant 4, so the y value is going to be negative. Okay, and secant. Emily, to find secant, how do I do that?
Okay. Okay. Let the x or 1 over x.
Yeah, take the x value and flip it. So what do you get here? What's your first step if you flip that x value?
Maybe like 1 over square root of 3 over 2.
Okay, go ahead. If you actually do that, what do you get?
The square root is in the bottom.
The square root's in the bottom, so tell me what would I write down?
I don't know. Would you flip it back to the top?
Well, you got to get it back to the top. Try not to think of it, when I think of it as 1 over x, it's going to get
It's gonna be
confusing.
the same thing, right? Yeah.
Don't think of it like that, because now it's like, what do I do here? Just think of it, this just means flip. So just take the x value
So
and
it's
flip
just,
it.
It's just square root of 3 over
2 over the square root of 3. Okay, so take the x value and flip it. Now we got to get the square root out of the bottom. So Gabe, how do I do that? Yep. And for a final answer there, Megan, what do I get?
2 root 3 over 3.
Yep. Okay. Any questions on that one? Okay. So, does anyone want to see or need to see one more of those? What would you do if we were going to do that? What would you do? Absolutely not. You're good. What would you have to do here if you were going to do it? Yep, I would change to degrees, and then what would you probably have to do?
Subtract 360.
Well, you're going to end up with a negative.
Oh, that's
I would add 360, and you're going to get an angle that's a multiple of 30 or 45. All right. So let's just kind of take a look at what we've done. Okay, first day, we did coordinates here, 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 here. 0, 90, 180, 270. Yesterday, we did 45, 30, and 60. Today, we took those points and we did the 45 in every quadrant. And then we did some 30s and 60s. We could have the 30 and the 60 here, 30 and a 60 mirrored here, and a 30 and a 60 mirrored there. So how many coordinates are there that we've done on a unit circle?
16.
16. Okay, so there's 16 different coordinates we've done. Now, I've got a diagram I'm going to put up that shows the triangles drawn for every single coordinate at the same time. So it looks a little confusing when you draw everything at the same time, but I just want you to see the patterns. Okay, that's all I want to really try to look at. So if you look at the red triangles, every one of the red triangles is a 45. They're all root 2 over 2. Every one of them. The only difference is sometimes they're both positive, sometimes they're both negative, or one of each. Right? If you look at the green triangles, those are the 30s. Those are all root 3 over 2, 1/2. Sometimes it's negative, sometimes positive, sometimes both negative. Okay, it just depends. So the only coordinates you really need to know are those three. And you really don't even need to know the difference between 1/2 and root 3 over 2 and root 3 over 2, 1/2. If you draw it correctly, you can just see that. You don't have to memorize the 30 and the 60 separate. And then the other coordinates, those are the easy ones. -1, 0, 0, 1, 1, 0, 0, -1. All right. So, any questions on the 16 points that we've done? All right. So, every angle that we've done or that you can see in that picture is a multiple of either what number or what other number?
30 or 45.
30 or 45. So, if we run into a problem that is not a multiple of 30 or 45, we can't do it with what I've shown you. Right? Like if I said, what's the sine of 12? You can't really draw a triangle and label the sides because we don't know that. Now, technically, if you know how to do 30s and 45s, you can do 15s. So you can do like 15, 30, 45, 60, 75. But to do the 15s, it involves something that we don't learn in this class. So we're going to just look at how to do anything that's not a multiple of 30 or 45 on the calculator. Let's look at this one. Sine of 18. I look at 18, I'm like, okay, not a multiple of 30, not a multiple of 45. I've got to do that one on the calculator. Now, that says sine of 18 what? Degrees. So, it's important on the calculator when you type it in that you are in degrees. So, on my calculator, I have a button that says mode, and I can change between radians and degrees. Right. On your calculator, it might be a little different. I think my calculators have a button that says DRG at the top. If you press DRG, then it'll give you a choice, and then you can pick which one you want. Okay, so I'm going to pick degrees for this button. Now just type in sine of 18. And if we round it off, the answer there is 0.31. That's it. Any questions on how to type that in? Now, on the test, you have to pay attention, especially if it's multiple choice. Pay attention to this. If it says degrees, you need to put your calculator in degrees. Okay, if it says radians, well, you won't see the little circle. Put your calculator in radians. There'll probably be like 4 or 5 of these in a row using the calculator. I've had some people have the calculator in the wrong mode for that whole section. Okay, you just have to look. Maybe some will be degrees, some will be radians, so you might have to switch. Okay. Just make sure you put it in the right mode.
What's GRD?
Those are gradients. It's another way to measure an angle, but we don't use it. Okay. Cosine 356 degrees. Okay. Already in degrees from last time, so I don't have to change anything. And what do you get if you put in cosine of 356? Yeah. 0.98. Let's check.
Or, wait, 1.0.
So when I typed it in, I got 0.998.
Yeah.
All right. So I'll round this one to 3 decimal places. Otherwise, I'd have to round it to 1. Right, so I'll just say 0.998. So it's pretty close to 1. Okay. Let's look at this one. Okay. What would I have to do here to type that one in?
You have to find the sine and cosine.
You could find
Is there a button for that?
you could find the sine and the cosine and divide them because
I didn't. Alright.
it's actually something we're gonna do later on. But if sine is y and cosine is x, and we said tangent is y over x, tangent is really sine divided by cosine. So yes, if you didn't have a button for tangent, you could find the sine, find the cosine, and divide them. But we do. So we have a button for tangent, but something else I gotta be careful about. Yeah. I have to change to radians. okay, because that's the tangent of 2.4 radians. So go to your mode, change to radians, and tangent 2.4. Now, let me do what Anthony said. Let me find the sine and the cosine. If you do the sine of 2.4, and then divide by the cosine of 2.4, you get exactly the same thing.
How do we switch on our calculators?
So you have a button that says DRG at the top.
Okay.
You just scroll
Press
down
that.
Thank you.
So this one is about negative 0.92. Okay, so we did sine, we did cosine, we did tangent. Cosecant. Well, before I even type it in, what should I do on my calculator first?
You gotta change it back to degrees, right?
Yeah, let's go back to degrees so we don't forget that. So back to degrees. And now they want me to type in CSC, cosecant. Okay. Do I have a button that says CSC? No. How have we been finding the cosecant all week? What have we had to do?
Find the cosine first.
Find the sine, and then do what? Flip it. It's exactly what you have to do here. Find the sine of 247 and flip it. So you can do it like this. So find the sine, and now take that number and flip it. 1 divided by negative 0.9205. That's good enough. So I flipped it. Or if you want to type it in all at once, you can. 1 divided by sine 247. I think that's easier. That's a little different because I rounded, but it's about negative 1.09. So that's the only way to do the other three on the calculator. You have to find one of the other ones and flip it. Any questions on that? Okay, so let's try secant. Secant of 6, what is that? 6 what? Radians. Okay, back to radians again. So mode, radians. Okay. And now, how do I do the secant on the calculator? Yep, we're going to do what with cosine? Okay, and then do what? Flip it. So I'm going to do all that at once. 1 divided by cosine of 6. You're finding the cosine, and you're flipping it. So you get about 1.04. Any questions on that one? And last one we'll take a look at is cotangent of 13. Okay, what do I have to do here? Change back to degrees first. Yeah. So maybe it'd be simpler if you look at a bunch of problems and do all the ones in degrees first, so you don't have to keep switching, and then do all the ones in radians. It's up to you. All right. So back to degrees. Degrees. And which function do you use to find cotangent, since we don't have a button for it? Tangent, but then you have to flip it. So 1 divided by tangent is going to give you about 4.33. So any questions on that? Okay, so that's everything that's going to be on the test. So the test is going to have probably about 17 or 18 questions. Each question will have 2 parts. Okay, find a coordinate, then find the answer. Except the calculator ones, you don't have to find coordinates. Okay. You can't really find coordinates for these. You just type them in. So homework tonight is 49 to 57 odd. 67 to 81 all. So you got 15, 20 minutes. Okay, so please use the time to get started. If you finish it, you can show me. If you don't have a calculator, then I would do 67 to 81 now, because those are all calculator questions.